Okay, so the first new concept I wanted to go over was something called arc length. Basically, what the arc length is, it's just the measurement of a piece of the circumference. So we kind of talked about earlier what an arc is, right? We said an arc is just a piece of the circle. All right, it's just a piece of the circle right here. So, but in this case, this is asking for the exact measurement of this length right here. So there's a special formula, right? We call it the arc length formula. So we just write L, that's going to represent the arc length. All right, this guy is going to represent the arc length. Whoops, I wanted red. There we go. All right, this is going to represent the arc length L. And then we know that okay, this is just a formula, 2 pi r. If you notice this piece right here, the 2 pi r is the circumference, right? That's the circumference right there. And then this little piece is the extra piece that we have here. So it says x over 360. Notice how in my circle here let's use a different color. The x is the angle that covers that arc. So when we're using this formula, you have to be really careful just to make sure that you're using the correct angle that corresponds to the arc that you're looking for. Let's go ahead and look at an example of finding the arc length. All right, so I have two examples here. Let's look at example A. Let me look at my directions. Find the arc length of the given arc YZ. So I'm looking for this arc from Y all the way to Z. Let's go ahead and start with our formula. All right, I know my formula is L equals the circumference times x over 360. All right, so this is the circumference, and this is the piece of the circle that I have, right? So we know the radius. So 2 times, I'm going to replace pi with 3.14. I'm going to replace r with what it's equal to, 4. And then times, now I need to find what's that angle x, right? What's that angle that's going to go right up here? Yep, it's going to be 75. So we've got 75 degrees over 360. Okay, and we know it's 75 because this angle is the angle measurement that covers the arc that we want. Okay, perfect. So let's go ahead and we're just going to plug this into our calculator. Again, I'm using my iPhone calculator, so I can't quite just plug it straight in. So I'm going to have to do any sort of fractions first. So I'm going to do the 75 over 360 first. So I do 75 divided by 360. So I got 0.208333333. So let me scoot this down. So 0.208 and then 3 forever. Let's go ahead and bring everything else down. Whoops, that's too big. Times 4 and then times 0.2083. So let's plug that all in. So 0.2083333 times 4 times 3.14 times 2. And my arc length is equal to 5.23 inches. All right, let's go ahead and look at this example. So I'm looking for the arc length of y to z. So here's y, and then here's z. All right, so same idea. I've got L equals to 2 times pi times r times x over 360. Let's go ahead and plug in everything we need to know. So 2 times, let's plug in pi 3.14 times, plug in the radius. So in this case, the 10 represents the diameter. So that means that each little radius is going to be half of that, which is 5. So times 5, then times x over 360. So what do you think my angle x would be? Yep, and it is going to be 130. So 130 degrees over 360. So I'm going to go ahead and just divide 130 by 360. So this is going to give me 0.3611. And I'm just going to multiply that to everything else. Alright, so 0.3611 times 5 times 3.14 times 2. And I get 11.338 centimeters. And there we go. So the last concept that I wanted to cover is called the area of a sector. So just like the arc length was a piece of the circumference, the sector is going to be a piece of the area. So the formula is basically the exact same thing. You know what? Although we don't call it L. For a sector, we're going to call it S. So we call sectors S, right? So S, the area of the sector, is equal to pi r squared times x over 360. Right? So notice how this x over 360 is here again, and notice how this is the formula for the area. So the only thing you really need to memorize is the x over 360 part. Alright, so now let's go ahead and let's look at some examples of this. Alright, so we've got two examples. Let's go to example number 1. So we know so I'm asked to find the area of the shaded, find the area of the sector that's shaded. So I'm looking for this area right here, right? Everything within this area. So let's go ahead and start with the formula. Right? The formula says the area of a sector is equal to the area of a circle times x over 360. So we know how to find the area of a sector. It's just pi, so 3.14 times the radius squared, so times 8 squared, and then times whatever the angle is that covers that area over 360. So in this case, we can see that that angle 72 is going to be my x. Alright, so I'm going to go ahead and put 72 degrees here, and just plug everything in and multiply it all together. So I need to evaluate the 8 squared first because my calculator can't do that all at once. So 3.14 times 8 squared is 64 times, and I've got to calculate 72 over 360 as well. So I'm going to use my calculator for that. So I've got 72 divided by 360, and we got 0.2. Let's go ahead and multiply everything together. So 0.2 times 64 times 3.14, and it's equal to 200.96 centimeters squared, since it's area, right? That's the area of that sector. Let's go ahead and look at example number 2. So for example number 2, same idea. I want the area of the shaded region here. Right, so this is the area that I want here. We're going to start with our formula. So our formula is the sector is equal to pi r squared times x over 360. So we know pi is equal to 3.14. We know the radius is 10.8, and then I have to square it. And then we just need to figure out what is the x over 360 part, right? That's the only part we need to know here. So this is where you want to be really careful, right? The 81 degrees is only covering the part of the circle that's not shaded. But I need to know the part of the circle that is shaded. So if you look at the relationship between the 81 degrees, the angle of the 81, and the angle that corresponds to the shaded area, notice how it makes a full circle, right? It makes, or I can see it makes a full circle with them all together. So that must mean that they equal to 360 to 360 degrees. So what I'm going to do is off to the side, I'm going to find the area of the remaining piece, the part in the red, by subtracting from 360. So I'm going to do 360 minus 81, and that's going to give me the angle that corresponds to the shaded region. So 360 minus 81 is going to equal to 279 degrees. So that's what this equals now. So that's my x. My x is 200. Whoops, my x is 279 degrees. So let's go ahead and calculate this. I'm going to calculate this. 279 divided by 360 is 0.775. 10.8 squared is 116. Let's do that in a different color. Is 116.64. And then we're just going to bring down the 3.4. So multiplying that all together, and I get S is equal to 283.84. Looks like it's inches squared. Alright, so those are all the concepts for this lesson. You guys are going to have a few worksheets to go over. You guys are going to have some guided notes. And if you guys have any questions, feel free to come into office hours, which are Tuesdays and Thursdays from 9 to 11. Alright, good luck, guys.